in the workbook. Thank you. One page. Gotcha. All right, so if you look at page 57, it's got two boxes that look a lot like this. This is just like a note-taking tool that we're going to be using. We're going to talk about two different kinds of data analysis that we're going to look at. The Frayer model thing is just what this box thing is called. It's called a Frayer model. It's just a note-taking tool. So we're going to fill it in. I'm going to show you what pieces go where. I mean, I could just hand you the data and expect you to figure it out.
Oh, never mind.
Thanks. So maybe let's not boo when I'm giving you stuff. So we're going to fill in information about two different types of data analysis that we're going to do. So our first one, we good? Don't break my stuff.
Yeah, don't break the table frame.
Treat my stuff with respect, like it's your grandma's. Treat my stuff like your grandma bought it. What are you pointing at?
There's somebody outside the door.
I was going to say, if my door is a distraction, what we're going to do, we're going to make that less of a distraction. Kindergartners. Kindergartners. They stealing stuff out of each other's backpacks, causing ruckuses. Kindergartners in the back row over there. Kindergartners. I would recommend it because right now we still acting like kindergartners. With hopefully fewer bathroom accidents. All right, so our first thing we're going to talk about is something called univariate. Univariate. Do not have spray paint here. We're going to talk about univariate data. So, what might univariate data be? Excellent thought, but not quite. So uni won't be universal. What might uni be? What other things do you know that have uni as a prefix? United, but that's more uni. Unicycle? Unicycle has how many wheels?
3.
That would be a tricycle.
Oh, 1.
A unicycle or unicorn has one horn. Unicycle has one wheel. So this would be 1. You said it with a lot of confidence. Variate means variable. 1 variable. We talked about yesterday what our variable was. If we think about that big page we wrote down on, a variable is the pieces of information we recorded about a case. So this is looking at one piece of information. If we look at one piece of information, that could be everybody's heights, the superpowers we picked, the amount of sleep we said we got, the amount of text messages we said we sent. 1 variable. So univariate, what we put in the top left corner of these Frayer models, this is our definition. So this is 1 variable. Of data. So univariate is that we're looking at one variable. Our variables being the things we found information about. Height, the foot length, superpowers, all the other things that they asked in that survey. So the way we measure, which I'm going to put in the other corner, the way we measure univariate data, we wrote it down yesterday. It's our measures of center. When we talked about our center, that's when we talk about our mean. Whoever's music is on, it's way too loud. Median, mode, those guys. Or we can use our measures of spread. That was our standard deviation, our interquartile range, those kinds of guys. We're going to start for sure with mostly dealing with measures of center, but we'll get into measures of spread eventually. Freyer model. 2 of them. That's it. All right. It's like it's one of those. It's a tool. I don't get it. I'm doing it, but I don't like them. I don't get them. I don't see how they're helpful, but it's a thing. Measures of center and measures of spread. We wrote them down yesterday. Our centers was our mean, median, mode, and our spread is like our standard deviation. Our quartiles, we started talking about them a little bit yesterday. Talking about our the range. Those are all ways of measuring how far apart the data is. So when we're looking at these univariate data samples, we have different ways we can show them. We could do something like a dot plot, not a Donald Duck plot. No quacking, please. So dot plots are where we take and we make like little dots for every value that we have. And they could look things like this. Kind of looking at a vague shape, but it has a point for every data piece. We could do something called a histogram, which is very similar to a dot plot. It's going to usually follow the same kind of shape, but we just don't usually draw the dots. So it's looking at the same kind of shape. It could be a line. It could be made of bars. It could be a bar graph. But histogram and dot plots are very, very similar. We could also use something called a box and whisker. We will see these a lot. A box and whisker looks like this. Like that. That is a box and whisker plot. And in fact, if you go on Canvas into the gradebook and you click on the little square, it'll show you a box and whisker plot with every single assignment that you do and where your score is relative to everyone else in the class.
I haven't seen one of those in
Where?
2 years.
In Canvas.
What?
In grades.
In the box of whisker.
I've never seen those in years. I don't think that's something you can see.
Yes, it is, because I can see that much stuff for IU.
Years ago.
In fact, I'll pull up my gradebook for IU and show you. I'll show you where it is.
Please do, because I'm curious. I gotta pull this up.
All right. So those are the 3 ways we're going to show the information. And then we're going to talk through an example or so. Whoop. So our example of univariate data could be something like the average height of people in class. Or what was the most common favorite season? So it has to be data that we know in order to be able to make predictions of it, but we can use the data that we collect to gather that. Well, I knew I hadn't turned off. Whisker, that's the picture at the very bottom. Whisker, that's a K.
But some assignments just have to be done.
Yeah, I think it has to be a certain amount of either submissions or in a certain category. But if you
I'm looking at all of them.
I'll show you where to get that. I got to put a score in for my test student. Okay, so I'll show you where to find the box whiskers on Canvas here when we're done with this. So univariate is just looking at one variable. So if we've looked at univariate and we have a whole nother Freyer model to fill in, what might we be talking about? If we talked about unicycles and unicorns and univariate, what might another option be? Bivariate data. Like bicycle. Aren't really bicorns, binomial. Bifocal. So bivariate data binoculars. They use that prefix a lot of times. Uni isn't used as much. We use uni and mono a lot. So our definition, it's two. Two pieces of data are collected and compared What are you talking about? Are collected and compared from each case. So it's not just that I have a whole bunch of people's information on height and I have a whole bunch of information about what people's favorite season are. I need to be able to have them connected. This person's height and favorite season. This person's shoe size and ring finger size. So it has to be able to compare and contrast the two of them. So I'm going to go down to our example so we can think about things. I'm going straight to examples so that we can use the examples that I give to think about how we could show them and what they're going to describe. Because if I just tell you what they're going to look like, we go, what? So we took two really big measurements when we did our thing, right?
Yeah.
We did arm span,
And shoes size. On the height.
arm span, and height. We are actually going to take our data from this and compare this, I think, the first week back from fall break. We're going to take our arm span and our height data and see if there is a relationship between arm span and height.
That's all 3 weeks old.
Well, it's just that we're not introducing the software until after break, and it's something we do in the software. So everything we do beforehand, we're going to do by hand and be able to do by hand very easily. So, and then we could look at our like left versus right hand. And does that have any impact on your favorite sport? So you could do handedness. Or you could do handedness versus superpower. So they don't have to just be quantitative. I need the conversations to stop. Ladies.
See, for the first time it wasn't us.
It wasn't you guys this time. All right, so these two are quantitative. These two were categorical. We don't have to have matching. I could mix, I could say arm span versus superpower. Maybe people with really long arms want to fly. We could look at that comparison. What's up?
What was handedness?
Handedness would just be left and right hand.
Okay, and then where they come?
That says superpower. So I'm just comparing. I'm just making things up. They could be ambidextrous. And maybe people who are ambidextrous are like super duper into time travel. But we could analyze that using bivariate data. See what those corrections are. So that's what this is about. Bivariate data lets us connect two pieces of information like handedness and favorite sport or shoe size to favorite sport. I don't know, I'm just pulling, I haven't looked at the survey in a while. Those are the ones I can pull off the top of my head. Okay, so when we look at these, if we think about something like our measurements of our arm span versus our height, and I wanted to put both of those pieces of information on a picture, what might that look like?
Can I also say, I know what it is, but I don't know its name.
Uh-huh.
It's like bar charts on top of each other.
We're not going to use those.
Oh, we're not?
Why? That's kind of a dual histogram. It's like it would be a multivariate histogram. And they're very difficult to read unless you know what you're looking at.
Well, obviously you have to put a key.
Yeah.
And that's why.
I am definitely not spelling that right.
And that's why I wanted to run it by you.
Yeah. We're going to be using things like scatter plots.
Bar chart.
Bar charts a bit. Bar charts is more univariate though. It's more counting how many you have of a certain thing. It's not really comparing two things. Bar charts tend to compare one thing. So things like scatter plots, maybe even with like, a line of best fit. Oh, snap, blend those back up. Or we could have something, when we have categorical data, it's going to tend to show up in things like, we saw these in Algebra 2. Take a breath, children. Two-way tables, where I would have, right-handed, left-handed. Maybe we want flight versus teleportation. Yes, we could also have ambidextrous. I'm just like making one up here. So this is called a two-way table. And you saw these in Algebra 2. I'm just making one up. And it can have more information than that. I could put lots of boxes out. They can look almost like an Excel spreadsheet. Because that's kind of where a two-way table was born. So two-way tables we're going to use a lot. Scatter plots we're going to use a lot. Yes, dear. That would be a positive correlation. I was going to say, yeah, you're doing great. Yep. Yeah, this shows up in more than just math. Two-way tables show up in science a lot. Think Punnett square. Scatter plots show up a lot in all kinds of different things. Science, psychology, sociology. They'll both show up in physics. Oh, that was definitely meant to be in the bottom one where it has display. That's okay. That's okay. We're using the vibe of the Frege model. So things we're going to use to analyze, things we're going to use as measures. We're using the vibe of the Frege model. It's just the vibe. So that would be things like the equation of the, I'm going to give you a fancy schmancy name for it, regression line. Which is fancy schmancy math talk for line of best fit. That's a T.
Least regression line.
Yes.
You don't have least in there?
Now I do.
Yeah, we gotta correct it.
I know. We can also use something called our, y'all are having too much fun, our correlation coefficient, which is going to drive you nuts because we're going to use R squared most of the time. Dude, you are in this generation.
Be quiet.
Well, no, it's in alpha now.
True. You don't have to.
But if you're talking about people in this room,
Oh.
no, it's not.
But we're last two now.
R value is going to be something we use. Our correlation coefficient. Computer calculates it, but most of the time our computer calculates are squared. So that's going to drive you a bit nuts. No tables, computer. No R tables.
Hey, I like the R table. I actually understood them.
Awesome. I'll show you how to run on the software. Okay, because we're going to introduce the software right when we get back from 12 break, just because I don't want us to teach it to you and have a week off and then have to reteach it again, because that's 100% what would happen.
Do they work on both laptops?
Oh, yeah, no, what's that now?
Okay, because...
Where? Sorry, be more specific.
Correlation coefficient. That's what it is.
Correlation coefficient.
R variant.
R value.
There. Where are you going to go?
I would have taken valve, but I don't think. Okay, I can see the R.
What's that letter?
Value. I'll fix it.
Copy this.
It's what happens when I talk and write at the same time. My handwriting gets worse.
I can't write it in the it's an ADHD.
I can have it be nice if I try. If I try and talk and explain. And why are you using him as a table?
I can't see. That's why.
I have chairs that are closer to the screen.
No.
Many of them.
Yeah, go there.
That might be.
Go up there.
Okay, so we're gonna talk. We're gonna use all kinds of different data
So I want to be on this.
as we go through this chapter. We're gonna deal with all kinds of different things. So I know this is a lot of like data dump. We only have one more day of data dump, but it's a lot more interactive. So tomorrow we'll also have a fair bit of writing when we fill in the table on the next page.
Aww.
I know, this chapter has a lot of vocab, sorry. But since we still have some time, I want to show you a couple of things on Canvas, and then I'll talk us through a couple of the homework questions, just because we have time.
Yes, we have homework.
Yes, we have homework.
Tomorrow.
What's the 8-1 home?
That's what we're going to talk about.
Hip hip hooray.
All right, so first things first, I want to show you in Canvas. I just told you we could find a box and whisker plot. This is a test student. This is literally no one here. I made up a value. I just put a test score in for them so we could see it. Where did the test go?
Well, they got an 80.
There it is.
So.
Nope. So if you click on this little square that has a little plus and a checkbox in it, come on, open the thing. Oh, it's because
No.
this is a test student.
Go all the way up to the top. Click show all details.
Well, this is not going to work because it's a test student.
Yeah.
So if you click that,